Hello students, now we'll start with further on Venn diagrams in continuation with the topic set. So as you can see here in the diagram figure 1.2, you can see in a square the elements mentioned are 1, 3, 2, 4, 6, 8, 7, all these numbers. So here U is a universal set, okay, and universal set has all these elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, right? So all these are the part of universal set. So let me write that. It could all up to 10. I'm not writing all the elements. So this is called universal set. Okay. Whereas set A has all the elements in A because they are inside circle A. So the elements are 2, 4, 6, 8 and 10. So this is set A, and there are some things which is not in A, right? Not a part of A, but that is a part of universal set. So I can say that it is A complement. Complement means not in A, right? Let me write that, not in A. So which are those elements not in A? It is 1, 5, 9, 7 and 3. So these are the elements which are not in A. So that is called A complement. Let me write that, A complement. A complement, or sometimes represented as A dash, or sometimes also represented as AC, C for complement, right? So good, let's move on. Let's discuss illustration 2. You can see here in a rectangle there is a universal set which has all these elements, and set A is a bigger circle and set B is a smaller circle, you can see. So set B has two elements 4 and 6, right? And set A has all the elements. All the elements means which are in B also, right? That is a part of set A. So that is why we will say 2 and 8 and 4 and 6 and 10 all inside the circle A is the part of A, right? So we can say that because B is a part of A is a larger part and B is a smaller part of A, so we can say that B is a subset of A, right? Subset means a smaller portion of that, right? Okay, fine. Yeah, good. So here if I ask, in this question if I ask what is B complement, those elements which are not in B. So not in B means everything outside the circle B would be the B complement, like 2, 8, 10, 1, 9, 3, 5, 7, right? Whatever is not inside the circle B will come in B complement. What is A complement if I ask? A complement we have discussed before is 1, 9, 3, 5 and 7, right? I'm not writing that. Let's move on. Let's understand what is union of sets. Okay, union of sets. Example 12, we'll see set A has the elements 2, 4, 6 and 8, and set B has the element 6, 8, 10 and 12, right? And we have to find A union B. Now union means all the elements which are in A or in B. A or B elements. So you can see here because we have to consider all the elements which are in either A or B. So actually we will be writing all the elements 2, 4, 6, 8, 10 and 12. Please understand, we have 6 in A as well as in B, right? 6 and 8 in A and B. So we will not write 6 and 8 two times. We will just write one time. Whatever elements are there in A or B, we will write it, all of them, right? So that is called A union B. We say A union B, right? Have a look at example 13. You can see example 13 has the elements. Set A is A, E, I, O and U, and set B is A, I and U. Now we have to show that A union B will be equal to A. Okay. So what are the elements which are in A? A, E, I, O and U. And what are the elements which are in B? A, I and U, right? So all the elements which are in either A or in B will be the part of the set, which is basically nothing but set A itself, right? Okay, let's move on. Let's understand the meaning of some of the properties. Now property first is, you can see A union B should be equal to B union A. Logically it should be clear that A union B means all the elements which are in A or B is same as all the elements which are in B or A. So that is called commutative law. Okay. Then you have associative law. A union B and then union C is same as A union of B union C whole, right? So that is called associative law. A union null set will be set A. Reason is simple. A is set A, all the elements inside A, right? And null set means nothing. So actually we are talking only about set A, right? Fine. Set property 4th and 5th is very, very easy. You can understand. Okay. Let's understand about intersection of sets. Intersection means common. Whatever is common between A or B will be called A intersection B. Let's say we have a element in A and B is 1, 2, 3, 4 and 5. So set A has 1, 2, 3, you can see, and set B has 3, 4 and 5. So which element is common between A and B? You can see element 3 is common. So we say that A intersection B would be set 3. We need to write it in the form of set. Okay. Let's understand how in Venn diagram they are represented. Here in this figure you can see set A is represented as a small circle and set B as a bigger circle. Now the common part which is in between A and B, that is called A intersection B, because that is the common part shared by both A and B, right? So that is A intersection B. Now what is A union B? A union B is actually all whatever is A or B. So you can see the yellow coloring, you can see. So either in this section or in this section or in this section, whatever is there in these three sections will be the part of A union B, right? Here if I ask, what is A complement? You remember A complement means what is not in A. So everything outside A will be the part of A complement. Let me color that. So you can see everything outside A means this red part or this part, right? That will be the part of A complement. All outside A. Great. Let's understand here what is disjoint set. As the name suggests, disjoint means there is nothing common between the sets. So you can see from the figure in a Venn diagram, set A and set B has nothing common in between them. That is why they are called. You can say that A intersection B is a null set because there is nothing common, right? The way we had the properties of union, similarly you can see the properties in intersection. You should memorize or you can understand. Okay. In this figure, first figure, you can see set A and set B and set C, right? What is the meaning of B union C? B union C means or in C within the boundary of B or C. So that would be, it doesn't matter A comes or no, but it should be all within the boundary of B. Inside that would be the part of B union C, right? Okay. In figure 2, if I say A intersection B, so you should not worry about C. You should only be worrying about A or B, right? It is A intersection B, so the common between A and B, that is a part, right? Whatever is there common between A or B. Okay. In third one, let's see. I will color it with differently. It says A intersection B union C. Now, first of all, we will have to color B union C, right? So, what was B union C? B union C was all this, all inside B or C, right? And this portion common with A. So in this portion, what is common with A? You can see here, this is the common part, right? That's the region represented by A intersection B union C. Great. So in this topic, actually no need to memorize the formulas. You will have a better understanding from the Venn diagrams only. Let's understand about difference of sets. Now you can see here set A in example 8 and set B is 2, 4, 6 and 8. They are asking find A minus B. Okay. What is the meaning of A minus B? Means all in A, all in A and not in B. All in A without. You have to remove whatever A has and a part of B. So you can see here 2, 4 and 6 is actually a part of B also. So that you will remove So A minus B is nothing but 1, 3, 5. So again minus B means all in A but not in B, right? So that is 1, 3 and 5. Now what is B minus A? B minus A means whatever is there in B except A. Whatever is there in B except A. So the elements of B you can see here 2, 4, 6 and 8. All these elements whichever are in A as well, they will be removed, right? So we are left with only 8. So B minus A set would be 8. Again repeating, B minus A means all in B without A. So we could understand here that A minus B is 135 and B minus A is just 8. So A minus B is not equal to B minus A, right? An important result. Okay. To do all the questions in Venn diagram, first of all you should make the elements. That will help you always. So let's have a look at number 6. Number 6 has set A, set B and set C and set D. First part is very easy. We are not discussing that. Let's talk about number 6. Number 6 says A intersection B union C. So first of all we'll find B or in C. So whatever is there in B or C, we'll find that first. So I'm writing B union C. 7, 9, 11, 13, 15, right? Whatever is there in B or C is B union C. So this is B union C. Intersection is the common part. So this set common with A is, you can see here 7 is common, 9 is common. These three elements are common between them. So answer for sixth part would be 7, 9, 11. So you always go one by one. First we found B union C and then we found the intersection with A, right? Let's do number 10. They are asking A union D intersection B union C. So first we find A union D. So whatever is there in A or D, we will write that first. I'm writing with red. So 3, 5, 7, 9, 11, 15 and 7. Whatever is there in A or D, right? Okay. Then we write B union C. Whatever is there in B or in C. So we'll write all that. 7, 9, 11, 13, 15. So this is B union C. Okay. We have to find intersection between them, means the common part. So you can see here what is common. 7 is common. 11 is common. And 15 is there. So 7, 9, 11 and 15 is the final answer.